Okay, number 4, find the area of the region enclosed by these three functions. We can see they're all linear functions. Easiest way to graph lines is the slope-intercept method of graphing. You can see for the graph paper I put on here that we're assuming a 0.5 scale on x and a 1 scale on y. I think for the most part for these quizzes I kind of put the scale on there for you that if you graph things correctly they should fit rather nicely on the graph. If they don't fit rather nicely on the graph, chances are you didn't graph it correctly, so be careful with that. So, if I take a look at this one, I'm going to make it say y equals, so that'll be 4x minus 3 equals y, would be the easiest way. Move the y right and the 3 left. That's a y-intercept of negative 3, which would be right here. And a slope of 4, so every time I go up 4, 1, 2, 3, 4, I go right 1, but again, paying attention to the scale here, that's a 0.5 scale on x. So 2 dashes to the right represents a move of 1. 1, 2, 3, 4 up, 1 over to the right, 1, 2, 3, 4 up, 1 over to the right, 1, 2, 3, I can't fit any more on there. And if I connect those with a nice straight line, I'm assuming, you know, the points of intersection will find their ways in there. If they hit nice, pretty points of intersection, great. If not, we'll have to do a little bit of systems of equations to figure that out. But let's just assume for now that it's going to be somewhere along there. And if it is, great. If not, we can extend it further and again find points of intersection. If we move on then to the second function, this one, I want that to say y equals, I'm going to say x plus 1 equals 2y. Divide everything by 2, so I get 1/2 x plus 1/2 equals y. So I have a y-intercept of 1/2 and a slope of 1/2. I'd rather find a pretty point that's easy to work with. If x equals 1, 1/2 times 1 is 1/2 plus 1/2 is 1. So 1, 1 is a point on this graph. So 1 right, 1 up, which would be right here. Notice that's a point that's on the other graph, which is great. Again, that's not going to be guaranteed to happen, but kind of look for that possibility. You don't always have to use the intercept. You can, again, go find some friendly integer point to work with like that. If I go up 1 and right 2, and again, be careful, that's only 1, so there's 2 there. And if I go up 1 and right, I can't do it again, so I just get those 2 points. If I connect those with a nice straight line, like so. And again, I'm just making an assumption that it's going to be in there, but maybe, again, maybe I have to extend it further, we'll see. And finally, I got 3x plus y equals 11, which of course is y equals negative 3x plus 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right there. And then negative 3 slope, so down 3, right 1, down 3, right 1, down 3, right 1, and we can see that point of intersection there. So thankfully all the points of intersection are friendly. So if I connect those dots like so, I would, but all I really have to do is figure out that little bit there. Now on this problem specifically, the way I would go about doing it is I would just draw a dashed line straight down off of here, like so. And if you look to the left of the black dotted line, the blue graph is on top and the green graph is on the bottom. And if you go to the right side of the black line, the red graph is on top, the green graph is on the bottom. And we can see that this is x equals 1, this is x equals 2, and this is x equals 3. So from 1 to 2, it's blue minus green. So blue would be 4x minus 3 minus green, which would be minus 1/2 x plus 1/2. And then from 2 to 3, I've got red minus green, so that's going to be negative 3x plus 11 minus 1/2 x plus 1/2. That's the easiest way to go about doing this with integrals. So I create two integrals, one for the 1 to 2 where blue's on top of green, one from 2 to 3 where red's on top of green. And my answer, my way of getting the answer is going to be this integral. And if I subtract, that's 8 halves minus 1 half makes 7x over 2. And that's negative 6x, or 6 halves, negative 6 halves, minus 1 half makes minus 7 halves dx. We're going to add that to the area from 2 to 3, and that's red minus green. Here's red, here's green. And again, this is minus this, and this is negative 6 halves minus 1 half is negative 7 halves x. And this is positive 22 halves minus 1 half is positive 21 halves dx. So it's simple linear integrals going on here. Not super hard to do, but again, just a matter of getting them set up correctly. And if I just work it out, then I'm going to get 7x squared over 4, increase 1 by 1 to 2, divide by 2, that doubles the bottom, minus 7x over 2, just stick an x on the constant, goes from 1 to 2. Same thing here, if I bump that up to a 2, I'm going to get negative 7x squared, divide by 2 on the bottom, doubles the bottom, makes 4. And I'm going to get plus 21x over 2, again just sticking an x on the constant, that goes from 2 to 3. Put 2 and 1 in there, put 3 and 2 in here, and work it all out. So if I put 2 in, 4 times 7 is 28, divided by 4 is 7. 7 times 2 is 14, divided by 2 is 7. If I put 1 in, 7 over 4 makes 7 fourths, and 7 over 2 makes minus 7 halves. Use some colors here. That was this one, and that's this one, so plus. Okay, so if I put 3 into this one, I'm going to get 9 times negative 7, so negative 63 over 4. If I put 3 in here, I'm going to get 21 times 3 is going to be positive 63 over 2. Minus, if I put 2 in, I'm going to get 4 over 4, so that's negative 7. And I'm going to get 2 over 2, so it's going to be plus 21. Okay. A couple fractions in both, so it looks like 4 is the common denominator for everything, so obviously that's 0, so I'm not going to work with that. So I'm going to get negative 7 fourths, I'm going to get plus 14 fourths, minus that, and then minus makes plus, double makes 14 fourths. For the red stuff, I've got minus 63 over 4. I've got plus 126 over 4, double. That's going to be plus 28 over 4, and that's going to be minus 84 over 4. So everything's over 4 now, just a matter of adding like terms, or I should say adding all the positives and negatives. So if I add the positives, 126 and 14 is 140, plus 28 is 168 over 4. Add all the negatives, negative 7 and negative 63 is negative 70, minus 84 is 154. And 168 minus 154 is 14, so we get 14 over 4, which reduces to 7 halves.